Well, I'll make a little video right here to talk about the lab that's due a week from today, next Tuesday. You can find the lab either in the Chapter 5 module, Lab 3 Accumulating Change, or you can scroll all the way to the bottom to the Lab and Group Work files, Lab 3 Accumulating Change. All right, I've already downloaded the lab. All right, and we'll see how this goes with the weather and the smoke, but I'm going to keep this due next Tuesday, November 21st. I'll send out a message if that changes. All right. Also to note, I posted 3 links, the same links I gave on the first lab on how to create graphics and import graphics on Excel and Google Sheets. But I want to go through right now and show you how to do that for this lab. All right, so the derivative tells us the instantaneous rate of change. The derivative is just rate of change for some function. And what can we say about the function itself? Suppose we only know about the rate of change. So we've got this scenario. Suppose the town's having a drought and wants to know how quickly the water supply is being used. So they send someone down to measure the rate out of the reservoir every 2 hours. So every 2 hours, they send someone down and figure out the rate. You measure the water flow out of the reservoir. And then I have this tabulated in a data set. So I'm assuming that the rate of the water flow out of the reservoir varies over time. This isn't showing. There we go. Okay. So first thing you need to do is download and open the Excel file Accumulating Change. So the canvas right underneath the lab, there's an Excel file. So make sure to download that. It will look like this. Make it a little bit larger to see. One note thing, if you don't have Excel or can't open this, let me know. Send me an email. I could put this in a Google Docs file for you to use instead. Or if you prefer Google Docs, you can always just copy and paste this onto a Google Doc. Okay, so look at part 1. All right, on sheet 1 is the set of measurements of the rate that flows out of the water in 2-hour increments. So the sheet are down here. This is called a workbook, and each workbook could have different sheets. So instead of sheet 1, I should change the lab. This is the 2-hour increment. Later in the lab, you're going to look at 1-hour increments. So we have twice as much data right here. And then half-an-hour increments. But for right now, for this video, we're going to stick with the first couple parts, is looking at the 2-hour increments. Number 1 is just to make a graphic, make a plot of the data. All right, so this is going back to the first lab. You highlight the first 2 columns, insert, and scatter. And here we go. I have the gallons per hour and titles. This right here is actually your gallons per hour. Oh, excuse me. X-axis is just hours. Add the vertical axis. This is gallons per hour. And of course, you can rotate it if you want this to be vertical. Okay, so we have a graphic, and this is looking at the water flow rate. So right here, this corresponds to midnight. The measurement is 3,900 gallons per hour. All right, so copy this over. Use Google Sheets. Slightly different scenario to get your scatter plot. Make sure to give it an appropriate title. Make sure all the axes are labeled when you import it to your lab report. Excuse me. Let's go here. All right, and make sure to make a short description of the lab. And for all graphs and figures, make sure to write a sentence or two explaining what the audience is looking at. Okay, part 2 is now to estimate the amount of water that flowed out of the reservoir during each 2-hour interval. We'll do this by assuming that the water flow rate does not change during each 2-hour flow interval. And that change occurs in sudden steps every 2 hours. This is kind of ridiculous. So imagine right here, if we were to make a curve of best fit, the water flow goes up and then back down, then up again. It's a natural wave pattern of the water flow. But we're just going to assume for the first 2 hours, the water flow is fixed at this, say, 3,800 or so. And then the second 2 hours, the water is fixed at this 5,644 gallons, and so on. So I want to figure out the water flow. The way to do that is to double it. Move this over here. And just write total gallons. And notice if you multiply hours times gallons per hour, you just get total gallons. But I'm not going to multiply these two together. I think these are all 2-hour increments. So what I'm going to do right here is say equals, look over and type V2 times 2. I keep mine multiplied by 2 because we're going to assume that water flow is fixed or constant the first 2 hours. I'm going to click enter. Highlight that cell again. I want to multiply all these values by 2 except the bottom one. So I'm going to highlight my mouse in the bottom right corner until I see the black or white plus sign. Scroll down and I'm going to stop right here. So this is spell it out in the directions. So I'll drop down this formula from C3 to C13. But I want to mention really briefly, why do we stop right here? On this row right here, an hour 22, 22 hours after midnight, we're going to assume that flow rate is the 6,832 for the entire 2 hours and ignore this last measurement. So I'll put a note down here, total gallon estimate, 24 hours. And you can type equals sum, and then click and drag and highlight these, or just type C2 colon C13. And there we go. We'd have about 145,000 gallons would be the estimation in 24 hours. All right, and that is called the left-hand sum because we took the leftmost flow rate at each time interval. We'll talk about this more when we meet again. But if you look at that graph, what we're doing right here is we're taking this left point for the first 2 hours, and taking this left point for the next 2 hours, and so on. So when we get to that 6,832, highlight that. That is this point right here. We're going to assume that is the flow rate for 2 hours. So the left, you can just think about, we kind of take all the left points, and we're going to ignore the rightmost data point. So the rest of this lab, you're then going to switch up and say, well, if you take the right endpoints, what happens? And then as you move further in this lab, you're going to look at, well, what if we took more measurements? So instead of 2 hours, every 2 hours, you take every 1 hour, then every half hour. All right, hopefully this gives you a good head start. I do plan on giving you maybe about half an hour or so on Thursday's class to work on this lab and ask me questions. And unless there's more cancellations, this lab will be due next Tuesday, November 21st.